Hello everyone. Plan for today is to talk through the concept of the quadratic formula. We're going to talk through where it comes from and then through a few practice problems using the quadratic formula. On the screen is a rough paraphrase of the quadratic formula. And so if a quadratic equation is in the form of ax squared plus bx plus c equals 0, that's a pretty important if. In your math career, as you go through and you're reading textbooks and you see formulas, the if part is crucial. You have to get the if part. What it means is if an equation is written in any other form than that, the quadratic formula doesn't apply. If I have an equation that says x plus 2 squared equals 7, the quadratic formula doesn't apply. If I have x squared plus 7x minus 2 equals 9, the quadratic formula doesn't apply. And I would have to get those equations into the form ax squared plus bx plus c equals 0 before I could apply the quadratic formula. So the if part in every single theorem is pretty important. So the quadratic formula theorem says in order to use this thing, it has to be in that form. Okay? If it's in that form, now we have two solutions, and we can find those two solutions by taking this equation, negative b plus or minus, etc. Notice it says x equals. The values you get out of this quadratic formula will be values for x. Or they'll be values for this expression or that term right there. I could have 4y squared plus 3y plus 9 equals 0, and then my answers would not be x's, they would be y's. I could have 4 square root of x plus 3, I could have 4x plus 3 square root of x plus 9 equals 0, and then my answers would be square roots of x equal. There's lots of applications. I got to do one more. If I have 4x to the fourth plus 3x squared plus 9, my answer would be x squared. So whatever variable is written right here, that is the variable you are solving for. Or in some cases, the expression you're solving for. Okay? That was a side note that we'll build on in a little bit. Okay. So where in the world does this quadratic formula come from? It is not just some magical formula. It is actually derived. So let's derive this quadratic formula. We're going to do so by completing the square. In a previous video, we talked about how to solve by completing the square. So let's do that. We only have one number up here, so we're going to do that with a whole bunch of variables. And that's okay. It'll be a good practice. So think through the first step in completing the square. The first step was to get rid of that c, meaning move it to the other side with whatever's on the other side. Second step, the coefficient of x squared has to be 1. So we divided every term in our equation by the coefficient of x squared. Next step, I'm going to figure out what I need to add to this equation to make this a perfect square. And I did that by taking the coefficient of x and dividing it by 2. And remember, when we're talking about fractions, that's the same thing as multiplying by a half, and I get b over 2a. And I'm going to square that, and I get plus b squared over 4a. And so what I add to one side, I have to add to the other. Okay? Next step. We're going to factor this thing. And remember one of the comments I've made. When we factor, the term that goes inside the parentheses is always the term we get when we divide the coefficient of x by 2 before we square it. So when I factor this thing, this is going to factor into x plus b over 2a squared. And if that needs more explanation, go back to the completing the square video and watch that in detail. Okay? Or you can just practice and factor it, and you'll see it comes out to be that. Left-hand side, common denominator. In order to add fractions, I need a common denominator. Well, I need that a to be a 4a squared, right? No, a 4a. And I need this, that is squared. That's squared. Sorry, because when I square this over here, that should be a squared. And so I need this to be a 4a squared also. Well, that one already is a 4a squared. How do I make this first a 4a squared? I got to multiply the top by 4a. And so on top I get negative 4ac. Well, when I go back to the quadratic formula, I see something very similar. I see a b squared minus 4ac. So let's just change the order in that. I see a negative 4ac plus b squared. Let's write the b squared first. Why? Just so we can get it in the same format, because it doesn't really matter. Either way is fine, and we might as well make it look the same. All right, so we found our common denominator. We put them together on the right-hand side. We have our perfect square factored on the left-hand side. We have something squared equals some expression. How do I solve from here? Remember what I'm trying to solve for. I'm trying to solve for x. So my rule was to square root both sides in order to get rid of that square. And when I square root both sides, I generate the plus and minus. And now we're going to move the negative, or the b over 2a over, it becomes a negative. Remember, we cannot have a fraction inside of a radical, because what that really means is we have a radical in the denominator. So I'm going to square root the top, square root the bottom, and on top I get b squared minus 4ac. On bottom, the square root of 4a squared is 2a. Well, the denominators are exactly the same now, and I can add them together, and I get exactly what we had at the top of the screen. We get our quadratic formula. All right, that's where it comes from. Quadratic formula is pretty easy to use. So let's jump over here to another page. And I'm going to just use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so if you guys like little songs or little ditties that kind of help you memorize things, go on the internet somewhere and type in quadratic formula song. You will find all sorts to help you memorize that thing. All right, I am not going to sing one for you, though. Sorry. So first step, in order to use the quadratic formula, it has to be in the form ax squared plus bx plus c. We do understand that means plus or minus because the variables can be negative, equals 0. Well, it's equal to 1. So I have to get rid of that 1. I have to make it equal to 0 before I can use the quadratic formula. So I'm going to subtract 1 from both sides, and I get that. Now just simply plug it into the quadratic formula. This is a, right? Ax squared. This is b, and this is c. The sign in front goes with the variable. So a is 4, b is 7, c is a negative 6, and let's plug it in. So I get x equals negative b plus or minus the square root of b squared. I 99% of the time will do the b squared in my head, and I'll show you why in a second. I get it. Sometimes they're going to be messy numbers, and you can't. But if you can, I would highly recommend doing that in your head. Minus 4 times a times c all over 2a. Okay? Oh, sorry. 2a. And a is 4. All right. At this point in time, I could dump all that into my calculator. Okay? My calculator is pretty smart. Yours is pretty smart. It can handle that. Well, actually, rephrase that. It's programmed to handle order of operations. It's not smart in and of itself. It's as smart as you are and how you handle it. But we have a negative 7 plus or minus the square root of. We have, should we use our calculator? Let's grab our calculator. Maybe. Get rid of something I had on there before. Okay, so we had a negative, we had 49 minus 4. We have 49 minus 4 times a negative 6. And my fingers missed the minus. Still missed the minus. There we go. 49 minus 4 times a negative 6. And do make sure you look at your answer before, or your expression before you hit enter. What is underneath the radical is 145. All over 2 times 4, which is 8. Now, technically, we're done. There's my answer. However, I should answer some questions like, is there a perfect square that goes into 145? Will 4, 9, 16, 25, etc., will any of those go into 145? I'm kind of thinking maybe 9. Nope. 145 divided by 49? Nope. So we're done. Now, that would be an answer if it says leave your answers in exact form. Leave your answers in simplified radical form. Either one, that would be your answer. If your question asked you to write it rounded to the nearest hundredth, I would grab my calculator. I'd go negative 7 plus the square root of 145 equals, don't forget the equals, or either put an equal sign or parentheses, one of the two, divided by 8. Notice, that is different than negative 7 plus the square root of 145 divided by 8. That will not come out correct. It is the entire top term, negative 7 plus the square root of 145, that we're dividing by 8. So make sure you either put parentheses on top or you hit equals. My other answer is a negative 7 minus the square root of 145 equals divided by 8. So just depending upon how your textbook, how your test, how your quizzes, whatever, how your question is worded, which answer you would leave. Most of the time, you'll leave it in simplified radical form. But there's times, like a word problem, that doesn't make any sense. How long is a ball in the air? You wouldn't never say that. You'd say 25.24 seconds or something like that. You would round that to the nearest hundredth. So just depending upon the question. All right. Just like all my other videos, whenever you think you've got it, you try the problem out in front of me and come back and see the explanation. Solve. All right, so here we got negative b. Negative 1 is a positive 1, plus or minus the square root of b squared. Negative 1 squared is a negative 1 times a negative 1, which is a positive 1. Remember on the last problem I said I usually do that part in my head? Because, watch this, if I type in a negative 1 squared, why did my calculator give me a negative 1? I've heard a professor say, a calculator is nothing more than a high-speed idiot. Well, I'll tweak that a little bit because that's kind of like calling us idiots for not typing it incorrectly, because the calculator is only as smart as you tell it to be, right? You tell it what to do, and it'll do it very quickly. So tell it what to do correctly. We want the negative 1 to be squared. It knows order of operations. It squares first, right? Parentheses, exponents. It does exponents first. Then it multiplies by a negative 1. That's not what you want it to do. You want it to take a negative 1 and square it. So make sure you tell it what to do correctly, and it'll do it very quickly. But it won't, it's not any smarter than what you tell it to do. Okay? So next step. So negative b plus or minus square root of b squared minus 4 times a times c all over 2a. B with the sign, and C. All right, 1. Whoops, 1 plus or minus the square root of a negative 15 all over 4, which equals 1 plus or minus I square root of 15 all over 4. What is really nice about the quadratic formula is that it will solve both for real and imaginary solutions. It'll find all complex solutions. That's pretty powerful. That's pretty nice. All right. Done. That one's done. The next one. Negative b plus or minus the square root of b squared minus 4 times a, whoops, times c, all over 2a. If you do that, if you talk through the quadratic formula as you write down the letters, I guarantee you, you'll have it memorized after 4 or 5 problems. It doesn't take much to memorize that quadratic formula. All right, so 6 plus or minus the square root of, I see 36 minus 48, I see a negative 12, all over 2a. Let's reduce that thing down. I get 6 plus or minus, well, the square root of 12 can be broken into I. Square roots of 4, square roots of 3, right? Because 4 times 3. That's going to break down into 2i square root of 3 over 2. The 2 goes into both the 6 and the 2, so I get 3 plus or minus I square roots of 3, reducing the 2 into both of those terms. The square root of the negative is I. 12 breaks down into 4 and 3. Square root of 4 is 2. All right. Oh, this one's tricky. It's a messy fraction one. Hard part here is not the quadratic formula. Hard part here is getting it into the right form so you can use the quadratic formula. If you want, hit pause if you think you got it. Excuse me. Otherwise, I'll give you a tip. I'll wait for those who want to hit pause. Those who are still here, your tip is multiply the entire equation by the common denominator, by the least common multiple. Why? So you can clear the fractions. Okay, so let's do that. Multiply everything by 6, my common denominator, my least common multiple of all of the denominators. So when I multiply the x squared over 6 times 6, the 6's go away, and I get x squared. That's kind of nice. What the whole point was. In these two, the 6's go away, and I get 5. In this one, the 3 goes into 3 one time, and the 3 goes into 6 twice. 2 times a negative x is a negative 2x. Mission accomplished. The fractions are gone. Sorry. Sorry about that. My microphone just fell off. I have a wireless microphone, and I just stepped on it. For those of you who just get your ears blasted, sorry. Next step, put it in the right form. X squared plus 2x plus 5 equals 0. Put it in the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a gives me a negative b plus or minus, I see 20, I see negative 16. Reduces down to negative 2 plus or minus 4i, which comes out nice and neat as a negative 1 plus or minus 2i. No fractions. All right. Whenever you think you've got it, obviously you can hit stop, but here's another one. Put it in the right form. So we have 3x squared. Subtract x, I get negative 6x. Add 1, I get 5. And dump it in the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, which would be 6. But so I get 6 plus or minus the square root of 20 times 3 is 60. 36 minus 60 would be a negative 24 all over 6. This reduces down into I, square root of 4, square root of 6, right? So I get 6 plus or minus 2I, square root of 6, all over 6, which equals 1 plus or minus I, square root of 6, all over 3. A 2 can come out of all of the coefficients. All right, last one. Give it a try. Tough part, putting it into the right form. We need to get it into ax squared plus bx plus c equals 0. So I need to FOIL this mess out. X squared minus 3x plus 2x minus 6. Now, at this point right here, I have a couple options. I can move all the terms to the left like normal, but then my a will be negative. And that's not the end of the world, but most of the time people like to have the a positive. So I'm going to move, seems kind of crazy, but I'm going to move all of this to the right. So I'm going to leave this as a 0. I'm going to take everything off the left-hand side. I have a positive x squared, so I will subtract x squared from the 3x squared, and I get 2x squared. I have a negative x right here, right? We can all do that in our head. We have a negative x, so I'm going to add x to the other side. I have a negative 6, I'm going to add 6 to the other side with the 4, gives me 10. Now I can dump it in the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, which gives me negative b plus or minus, I see 80, I see a negative 79. This one doesn't simplify a whole lot. All right, that is the quadratic formula. Simple in concept, but there's lots of ways that that can be used.